Good morning, afternoon, or evening. How you doing today? Welcome back to Mr. Morrow's algebra class. Today we're going to talk about problem solving. We're going to introduce problem solving. Word problems are a big difficulty for most people. That is usually because they just haven't really fully understood how to translate words into mathematics. So hopefully today we can alleviate that problem and really bolster your skills so that when you see a word problem, you're not scared of it, but rather you're prepared to attack it and solve it. Now, in order to understand and solve word problems, you must first learn how to translate words into mathematical terms. That's huge. And first things first, though, remember that an unknown is a variable, usually expressed as x. Whenever you're talking about an unknown, that's your variable. That's what you're solving for. Sometimes there's two unknowns, sometimes there's three unknowns. Those would have to be labeled as separate variables. But every time you have an unknown, that is a variable. All right. Now, phrases to math operations table. Let's take a look at this table. Whenever you see the following words, these are clues or indicators that addition is being required. Okay? For example, sum, plus, greater than, more than, exceeded by, in excess of, added to, increased by, combined, altogether, together, total of. Anytime you see these key words, think addition. Okay, subtraction. We have difference, difference between, difference of, minus, subtracted from, subtracted by, less, less than. Let's take a little look at these two guys right here, okay? Less and less than. Big mistakes are made here, again, because it wasn't properly understood. So let's see if we can understand it. When I'm talking about just less, I mean just minus, subtract. So if I say, for example, 5 less 2, that's just 5 minus 2, which equals 3. If I say a number less 7, that's going to equal a number. That's an unknown. We don't know what that is, so that's x or n or w, whatever you want to call it, less minus 7. Okay, a number less 7. Less just means subtract, minus. Straight up, no tricks. However, less than is a different story. Less than, basically, whenever you see the than, think switch. You're basically going to switch the first term for the last term. What am I talking about? 7 less than 12 really means 12 minus 7. Whenever I have the less than, I'm going to put the last value in the front, and I'm going to put the first value in the back. So I'm just going to switch it. So that's why whenever I see less than, I always think switch. For example, 5 less than a number. 5 less than a number is x minus 5. Why? You have a less than. Switch. The number, which is the unknown, goes to the front. The 5 goes to the back. Switch. Okay? So please, let's just do one last example just so you can see it. A number less 5 is x minus 5. Done. Less means subtract, minus. A number less than 5. Less than, switch, 5 minus x. Okay? Hopefully that alleviates all confusions. In addition, subtraction can be indicated by decreased by, fewer, and fewer than. Multiplication of, that's the big one, of, 1/3 of, 4/5 of. Of means multiply. Please remember that. Times, multiplied by, product, product of, per. I have a little asterisk here, okay? A lot of people don't teach per as multiplication. They teach it as division, but I think it could really be used as both. For example, if I say CDs cost $5 per unit, and you buy 10 units, okay, what's your total cost? Well, in this case, per means for every, so $5 for every unit, 5 times 10 would be $50. So it depends how they use per. You have to be really careful. But per can indicate multiply. Twice, double, triple, that means multiply. Half, increased by a factor of, decreased by a factor of. If I just have increased by itself, okay, if I just have increased by itself, that's going to be addition. If I have decreased by itself, that's going to be subtraction. But if I have increased by a factor of means multiply, and factor are the factors are numbers that go into other numbers, so they're representing multiplication. So increased by a factor of or decreased by a factor of will indicate multiplication as well. And last, well, not last, almost last, division. I've got quotient, divide, divided, divided by, per, and ratio of. Notice that per has a little star here, a little asterisk, because like I had just said before, it can be used for multiplication or division. Let's see how it would work here. Let's use the same example, okay? CDs cost $5 per unit. What if I tell you now the total cost equaled, whatever, $40. How many units did you buy? Well, in that case, think about it. Per here, for every unit, that's what per means, every unit costs $5. So if I've got $40 total divided by $5 per unit, I'm talking about 8 units, 8 CDs. So per, please be careful, read the question, and see what it's telling you to do. All right, now last but not least, equals, is, are, was, were, will be, gives, yields, sold for. Okay, any of those means equal. Think about it. Is, are, was, were, will be. Those are all tenses of to be. Excuse me, I'm a little bit sick today, guys, so I do apologize. Is, are, was, were, will be. Those are all tenses of to be. And that's what equals means. All right. Let's put this into practice. Write each word phrase as a numerical or algebraic expression. Please remember that a numerical expression is just a number sentence involving numbers and operation signs. An algebraic expression is a number sentence or a numerical expression involving variables, numbers, and operation signs. When we add an equal sign, then we have an equation. But right now we're just going to practice writing word phrases as expressions. The sum of 3 times a number and 8. Remember, we don't know what this number is, so that means that's the variable. So the sum, we're talking about an addition. Okay, so we have the sum of 3 times a number and 8. Done. Here's your 3 times the number. Here's your sum. The number is x, golden. The difference of a number and 9. Difference, straight up subtraction. Numbers are unknown, so x minus 9. The product of -4 and 6. Product means multiply, so -4 times 6. The quotient of a number and 2. Quotient is talking about division. Numbers are unknown, so x divided by 2. Remember, fraction bar means division. Don't do it like this. You technically are correct, but you're going to have to convert that into a fraction anyway, so go ahead and use more sophisticated symbols. 9 less x. We talked about this one. Try to do it at home. What would 9 less x be? Okay, good job. Good job if you went 9 minus x. How about 9 less than x? Remember, less than means switch. Good. Let's switch it then. X minus 9. Hope you guys got those right. Or ladies out there. 3 times the sum of a number and 15. 3 times the sum of a number and 15. Because 3 was being multiplied to the sum. So when we're talking about something being multiplied to a sum, you have to encapsulate that sum with parentheses. You have to encapsulate that sum with parentheses. A number increased by 35. A number is the unknown, x. Decreased. Sorry. A number decreased by 35 minus 35. All right. Put some word problems to play. The Dolphins scored P points in a football game. The Jets scored 12 more points than the Dolphins. Write an algebraic expression for the number of points the Jets scored. Okay. Whenever we have a comparison type of situation, okay, this is what's called a direct translation word problem. We don't have a solution yet. We're not setting up an equation. We're building to that, okay? But whenever we're talking about a comparison, I cannot tell you how important it is and how much simpler your life will be if you simply make a table. So we're talking about the Dolphins and the Jets. The Dolphins scored P points. So the Dolphins scored P points. The Jets scored 12 more than the Dolphins. Well, if the Dolphins scored P and the Jets scored 12 more than the Dolphins, didn't the Jets score P plus 12? That's what we're looking for. That's the expression. This is going to help you significantly just in a few minutes when we're actually doing word problems that deal with comparisons. Let's try another one. Lumberman cuts a 50-foot log into 2 pieces. One piece is y feet long. Express the length of the second piece as an algebraic expression in y. Okay. We have the 50-foot long log is cut into 2 pieces. So how about this? Piece 1, piece 2. One piece is y feet long. So let's go ahead and say that piece 1 is y. What would piece 2 be? Well, let's think about this. If you've got a 50-foot log, okay, and you cut out one piece that is y feet long, aren't you subtracting that y from the 50? So what's going to be left? Your second piece will be 50 minus y. Let's think about this numerically in case this confuses you. Let's say, just for giggles, that I tell you that one piece instead of his y feet is 20 feet. What would the third piece be? Well, wouldn't you do 50 minus the 20 that you cut out and you had 30-foot piece left? That's exactly what I'm doing here, but with variables. I cut out y feet from the 50. So what's left over? 50 minus the y feet that I cut out. So that's my expression right there for the second piece. Okay, next. A number of quarters in a drink machine is 2 less than the number of dimes, D, in the machine. Write an expression for the number of quarters as an expression of D. Okay. We got quarters and dimes. The number of quarters in a drink machine is 2 less than the number of dimes, D. What do we know nothing about? Hopefully, you're thinking dimes. We don't know how many dimes there are. We know how many quarters there are. There's 2 less than the number of dimes, D. So dimes, since we don't know what it is, that's our D. We don't know how many dimes there are. But we do know that the number of quarters is 2 less than the number of dimes. So how do we write that properly? 2 less than the number of dimes? D minus 2. Why? Less than. Switch. And that will be the expression for the number of quarters we have left. All right. Sure you guys are doing really well. Hopefully this is starting to make sense. Let's kick it up a notch. When keywords is, are, was, were, will be, gives, yield, and sold for, just to name a few, are added to an expression, remember what we said, it becomes an equation, which can be solved, okay? So we're going to go ahead and start with some baby equations, baby word problems, and then we'll get into a little bit more difficult ones. Let's go ahead and just translate each of the following sentences into an equation. Hopefully you know how to solve these already, but let's just go ahead and translate them. 5 more than a number is 20. Well, 5 more than a number. 5 more than a number is means equals 20. 4 ties? No. 4 times the sum of a number and 3 is 15. So 4 times, remember you're multiplying something by a sum, so you have to encapsulate it in parentheses. 4 times the sum of a number, x, and 3 is 15. 5 less than a number is 45. Less than, switch. So x minus 5 is equals 45. The difference of x and 5 is the quotient of x and 2. Difference just means straight up subtraction. So x minus 5, the difference of x and 5, means equals the quotient of x and 2. All right. Hopefully this is making sense. Putting those words into mathematical phrases. This is the key. You can do these baby steps. You will succeed. All right, let's continue, guys. All right. There are going to be 5 main categories of word problems. And I want to describe them to you so that you know what to look for. You know how to start attacking each type. We're just going to work with direct translation today, but I want to just give you an introduction as to what you're going to see as the year progresses. Direct translation. Direct translation are problems in which we must translate English words into the language of mathematics by using keywords found in the problem. They usually involve a comparison between 2 or more entities. And we're going to see some examples of those today. That's what we're going to work with mainly. Geometry. Problems in which the unknown quantities are related through geometric formulas. Please start now. You must memorize geometric formulas. Area, perimeter of squares, rectangles, trapezoids, rhombuses, parallelograms, circles. Those are all very good to know. Triangles, got to know that. Mixture problems. Mixture problems are problems in which 2 or more quantities are combined in some manner or some form. Okay, you got 20% of this and you got 50% of that. You combine them and you get X% of this new solution. So that's the kind of problem that are involved in mixtures. Uniform motion. These are problems in which the formula D equals RT is used. Okay, where D equals distance, R equals rate, and T is time. Okay, T is time. I don't know why I put that is there, sorry. So distance, rate, and time. Distance equals rate times time. Okay, those are problems like train A leaves the station at 5, train B leaves the station at 6. If train A was going at 80 miles an hour and train B is going at 100 miles an hour, at what time or after how many hours will train B catch up with train A? That kind of a problem. That's uniform motion. And then last but not least, we have work problems. And work problems are problems in which two or more entities join forces to complete one job. So it may be two people, maybe two machines, two water pumps. It depends what the entity is, but they're working together to complete one job. Okay, now, when we talk about word problems, we have to talk about, you know what? Let me go ahead and switch slides here, my friends. There we go. Before we get into consecutive integers, sorry, there's a little slide mishap there. Okay, general strategies for solving word problems. Number one, identify what you are solving for. What is the variable or what are the variables you need to solve for? If you don't identify it, it's going to hurt you. Label it, okay? Label it. 2, label the unknowns very carefully. All the variables should be labeled. If X is there, you call X, the number of cookies, or Y is the number of crayons. It depends. Label your variables. Translate the word problems into an equation or inequality. Use your translation skills to turn that word problem into an equation or inequality. Solve the equation or inequality you created. You know how to do this already. You guys know how to solve equations, so solve it. Make sure that your answer is reasonable. Sometimes we set up the wrong equation, we solve it, and for example, we get a negative answer. And if they're talking about something that they sold or made or bought, you can't really make negative items. You can't really buy negative items. You can't have negative money. Okay, there is no such thing as negative people. So make sure that your answer is reasonable. Also, let's say you're going, something is supposed to be increasing, and your answer is a lot less than the original. Then you know you messed up. Should be larger, and vice versa. So please make sure that your answer is reasonable. And last but not least, answer the question. Find the value of the missing variables. Sometimes you set up an equation, okay, and you have to solve for x. And let's say x is 9. But then you have to plug that x back into an expression in a table that you made. And that would be your final answer. So make sure you answer the question, please. Okay, now, let's try some practice problems. Let's do some comparisons here. Direct translations. The price of the front row ticket to a concert is $69 more than twice the price of a general admission ticket to the same concert. If you purchased a front row ticket and your friend purchased a general admission for a total of $436.50, how much did each ticket cost? Okay. Whenever you attack these comparison problems, please try to remember the following. The second or last value is usually your unknown x. The second or last value is usually your unknown x. So let's make a table because we have a comparison. We've got front row and we've got general admission. Okay? Front row and general admission. Front row ticket costs $69 more than twice the price of a general admission ticket. So what do we know nothing about? Which is the second value here? The general admission ticket. So we know nothing about the general admission ticket, so that's X. The front row ticket is $69 more than twice the price of the general admission. 69 more than twice the price of the general admission. So the front row is 2x plus 69. Now you've made your two expressions. Let's put it all together for an equation. Together, if you purchase a front row ticket and your friend purchased a general admission ticket for a total of $436.50, how much did each ticket cost? Well, the front row ticket, 2x plus 69, plus the general admission ticket has to equal $436.50. Let's solve the equation, my friends. It's that simple. 2x and an x, that's 3x, plus 69 equals 436.50. Subtract 69 to both sides. Cancels. 3x equals, you've got 0, 5, you've got 7, you have to borrow. So that's 6, and that's 3. Divide by 3. Okay. Hopefully you're following my math here. Pretty simple. Don't forget to bring up your decimal point, please. And that's 5. So it's 15. Boom. Okay, so X equals $122.50. You are not done. You just solved the equation. Is it reasonable? Yes. If the total was 436, the general admission has to be a lot less than that, so it is reasonable. Now, follow directions. They want to find the cost of each ticket. So plug in your X. General admission was $122.50. Now you got to plug it in to find the front row. 2 times $122.50 plus $69 equals the front row. I just evaluated, plugged in the X value into that X. So that's going to be 245 plus 69. So you got 314. And if you add 314 plus 122.50, you get $436.50. Bingo, you're done. All right. Let us continue. Consecutive integers. You're going to see that phrase, consecutive integers or consecutive odds or consecutive evens. And I want you to really understand how this works. Consecutive means one right after the other. So let's just think of 3 consecutive integers. Remember, integers are whole numbers and their opposites. So 3 consecutive integers, for example, 1, 2, and 3. The starting number here in variable form would be your n. How did I get from 1 to 2? I added 1, so n plus 1. How did I get from 1 to 3? I added 2, so n plus 2, etc., etc., etc. If I say the sum of 3 consecutive integers is 15, 3 consecutive integers, your first integer plus your second integer plus your third integer, etc., etc., etc. So you're always adding one number more to n for consecutive integers. When you're talking about consecutive odd or even integers, let's think about odds first. 1, 3, 5. 1 is your original number, n. How did I go from 1 to 3? I added 2. How did I go from 1 to 5? I added 4. Let's think about the evens. Three consecutive even numbers are 2, 4, and 6. 2 is your original number n. What did I do to 2 to get to 4? I added 2. What did I do to 2 to get to 6? I added 4. So when we're talking about consecutive even or consecutive odd integers, you're adding 2 to every consecutive number. So if I say the sum of 3 consecutive odd numbers is 30, that would be your first number n, plus then m plus 2, plus then m plus 4, etc., adding 2 to each consecutive number. Let's do an example. The sum of 3 consecutive even integers is 324. Find the integers. Okay, let's think about our consecutive integers, guys. Make a table. Your first, your second, and your third consecutive integer. We're talking about consecutive evens. So your first one's n, your second one is n plus 2, your third one is n plus 4. And the sum of 3 consecutive integers is 324. So your first integer plus your second integer plus your third even integer equals 324. Now let's just solve it. N plus n plus n is 3n. 2 plus 1 is 3 equals 321. Subtract 3 to both 324, I'm sorry. Subtract 3 to both sides. 3n equals 321 divided by 3. N equals 107. You're not done. They want you to find the integers. So, whoa, what happened here? I did something wrong. I'm sorry, guys. I should have said the sum of 3 consecutive odd integers. And no, you know what? I totally messed this up because I don't know how to add, guys. I'm right. It is even. Let's do this correctly. I'm sorry. I don't feel very well today. I should be paying attention. N plus n plus n is 3n. 2 plus 4. I've got to be clear. 2 plus 4 is 6. Sorry about that. Equals 324. Subtract 6 to both sides. 3n equals 318. Divide by 3 to both sides. N equals 106. Sorry about that. The only reason I caught that was because we're looking for evens, and I had an odd number. I'm actually glad I made that mistake. I checked for reasonableness of the answer without even thinking about it. I found an odd number, but we're looking for an even number. So I must have done something wrong, and now I fixed it. So now we're not done yet. We got to find the integers. So we're talking about 106, 107, 108, and 110. Because 106 plus 2 is 108. 106 plus 4 is 110. So another one. The sum of 3 consecutive integers is negative 48. Find the integers. Okay, let's make a little table. We got our first integer. We'll call it 1, rather. I'm sorry. Second integer, third integer. First integer is n. Second integer is n plus 1 because we're talking about consecutive integers, not odd or even. Third integer is n plus 2. The sum of the 3 consecutive integers is negative 48. So n plus 1 plus n plus 2 equals negative 48. N plus n is 3n. 1 plus 2 is 3 equals negative 48. Subtract 3 to both sides. 3n equals negative 51 divided by 3. N will equal negative 17. So my first integer is negative 17. My second, negative 17 plus 1 is negative 16. My third consecutive integer is negative 17 plus 2, which is negative 15. All right. Hopefully that makes sense. All right, let's do a couple more. You're building a shelving system and cut a 14-foot length of oak shelving into 3 pieces. The second piece is twice the length of the first piece. And the third piece is 2 feet longer than the first. Okay, I want to find the length of all 3 pieces. Find the length of all three pieces. Okay, so let's make a table. Let's think about this. You're building a shelving system and cut a 14-foot length of oak shelving into three pieces. The second piece is twice the length of the first, and the third piece is 2 feet longer than the first. What do we know nothing about? The last one, the first piece. So let's talk about the first piece, second piece, third piece, okay? What do we know nothing about? The first piece, so we'll call that X. What do we know about the second piece? The second piece is twice the length of the first, so that's 2X. And the third piece is 2 feet longer than the first, so that's the first plus 2. Make a table, makes your life easy. Now, all these three pieces, don't they form one 14-foot length of oak? So we've got the first piece plus the second piece plus the third piece has to add up to be 14 feet. So X plus 2X plus X is 4X plus 2 equals 14. Subtract 2 to both sides. 4X equals 12. Divide by 4. X equals 3 feet. So my first piece is 3 feet. Second piece is 6 feet. And my third piece is 5 feet. 3 plus 2 is 5. Bam. Easy peasy. Okay, number 6. A total of $25,000 is invested in bonds and certificates of deposit. The amount invested in CDs is $8,000 less than the amount invested in bonds. How much will be invested in each type of investment? We have a comparison. Let's make a table. CDs, bonds.
Mass will be celebrated in the chapel in 5 minutes. Mass will be celebrated in the chapel in 5 minutes. All students and faculty are cordially invited. Also, Christopher de la Guardia.
Sorry.
Report to the attendance office.
Okay, sorry about that. Okay, so I have a total of $25,000 invested in bonds and certificates. The amount invested in CDs is $8,000 less than the amount invested in bonds. What do I know nothing about? The second or last variable usually. And yeah, I have no idea anything about bonds. So bonds will be X. But I do know that CDs is $8,000 less than the amount invested in bonds. So less than, remember, we're talking about switch. So X minus 8,000. And I know that the number I put in bonds plus the number I put in CDs has to equal 25,000. So X plus X is 2X minus 8,000 equals 25,000. Add 8,000 to both sides. So I've got 2X equals 33,000. Divide by 2. So X will equal 2 into 33. I just don't want to make a mistake here. And then we're going to have, 12,500. Okay, so 12,500 is the amount that I invested in bonds. No, that's wrong. I did my math wrong here. It's not 12,000. Wow, I'm having an off day. I really apologize, guys. Let's do this the right way, please. Mr. Moore's a little bit out of it right now. 1. That's 3. That's 16,000. Sorry, guys. My bad. Having a rough day today. So X is 16,500. I really do apologize. I should not have made that mistake. So 16,500. How much did I invest in the CDs? 8,500. 8,500 plus 16,500 is 25,000. So we are perfect, golden. Okay. Universe Phones has a long distance phone plan that charges $6.99 a month plus $4 per minute of usage. World Phones has a long distance plan that charges $5 per month plus 5 cents per minute of usage. For how many minutes of the long distance call will the monthly cost for the plans be the same? All right, well, what's our unknown here? The number of minutes. So X is going to equal our minutes, okay? Help yourself out always, label stuff. I'm going to make a table. I love tables. We're talking about comparison. We're talking about Universe Phones and World Phones. I know that Universe Phones has a long distance plan that charges $6.99 a month plus 4 cents a minute. So $6.99 plus 4 cents per minute X. Why X? Because I already defined it. World Phones charges $5.95 plus 5 cents a minute. For how many minutes of long distance calls will the monthly cost for the plans be the same? What does the same mean? The same means equal. So when are they going to equal each other? Let's set up an equation and find out. When will Universe Phones, which is $6.99 plus 4 cents a minute, equal World Phones, which is $5.95 a month plus 5 cents a minute? Let's solve for X. Put the variables together. So subtract 0.04x to both sides. If you want to get rid of the decimals, you guys can. I don't mind working with decimals, so I have no problems with it. But if you want to get rid of it, we learn that procedure. We learn that skill. Be 0.01x. Subtract 595 to both sides. So you've got 401 equals 0.01x. Divide by 0.01. X equals 104 minutes. So if you talk for 104 minutes, either plan will cost the same. Hope that made sense. Always using tables. All right. Well, I hope that made sense. Hope it adds to a lot of confusion. Thank you very much. Great lesson. Have a great day. Bye-bye, and thank you.